This is lecture 21 of the course on principles of behavioral economics. In this module, we are going to study about prospect and risk attitude. So, as I previously mentioned that we have begun with the third topic of judgment and decision under risk and uncertainty. So, under that we first talked about various concepts of probability that we are going to again utilize going forward while discussing prospect theory. But using those concepts of probability, we first discussed Bayesian analysis, some Bayesian rules and then Bayesian updating. Now, moving further towards the prospect theory, we are going to first define what are prospects and discuss risk attitude, how people perceive risk and how that can be modeled using basic graphs and mathematics. That is the main purpose of this module. Expected utility theory, which you have already talked about previously in various modules, and it is also a part of the neoclassical tradition. It has dominated the analysis of decision making under risk. It has been generally accepted as a normative model of rational choice and widely applied as a descriptive model of economic behavior. Thus, it is assumed that all reasonable people would wish to obey the axioms of the theory and that most people actually do most of the time. So, basically again the assumption of rationality prevails. Prospect theory of Kahneman and Tversky, primarily dealing with economic behavior under uncertainty, largely questioned the axioms of EUT and offered more realistic modeling of behavior under uncertainty. This module deals with one important aspect of EUT, namely the degree of risk aversion. So, first we define prospect and then using the concept of prospect, we will be defining different risk attitudes. Decision making under risk can be viewed as a choice between prospects or gambles. A prospect xp1 xn x1 p1 xn pn is a contract that yields outcome xi with probability pi, where p1 to pn adds up to 1. A prospect is like a combination of outcome associated with probabilities. So, if I go back to the simple probabilities or examples we were considering in the previous module, then say if I flip a fair coin, then the prospects are head will be appearing with a probability of half or 0.5 and the other prospect is tail and with a probability of half. Similarly, for when we roll a dice, then the prospects are 1 with a probability of 1 upon 6, 2 probability 1 upon 6 and so on. Thus, the final one is 6, the outcome is 6 with a probability of 1 upon 6. So, these are simple examples of prospects. To simplify notation, we omit null outcomes and use xp to denote the prospect xp 0 1 minus p that yields x with probability p and 0 with probability 1 minus p. So, basically suppose somebody is going to give me 10 rupees. So, there is actually the probability of not getting the money is 0. So, in that case 0 I will not be getting anything, that is I will be getting 0, the probability is also 1 minus p, that is 0. So, as a result of which, so we omit null outcomes. In that case I will be writing this as 10 1 and I am not going to get anything, that is 0 with a probability of 0 is not mentioned. So, null outcomes are basically omitted. Similarly, if the prospect is like I am going to get 10 rupees with a probability of 0.5 and 0 with a probability of 0.5, then again 0 with a probability of 0.5 can be omitted and we can simply write it as I am going to get 10 rupees with a probability of 0.5. In fact, this actually is written as 10. So, here since it is 1, the probability is 1, I do not need to even mention 1. So, as I just mentioned, The riskless prospect that yields x with certainty is denoted by x. So, I am going to get 10 rupees with certainty, I will be writing it simply as x. The present discussion is restricted to prospect with so called objective or standard probabilities. So, most often we would be having situations where there are probability values between 0 and 1, because if there is complete certainty, then there is no need of the discussion of probabilities. So, since this module is devoted to decision and judgment under risk and uncertainty. So, you would be dealing with some level of probabilistic events only. The application of expected utility theory to choices between prospects is based on the following three tenets: expectation principle, asset integration and risk aversion. These three are also can be called the three main pillars or very important assumptions of the expected utility theory. Now, we are going to discuss each one of them, beginning with expectation principle. A real valued function with the domain of an outcome or probability space is a random variable. The realized values of x are denoted by x1, x2 to xm or xn. So, the thing is that this is in the previous module also we discussed outcome space. We can also call it a probability space. So, for example, if I take the case of flipping a coin, then the outcome space would be h and t. Imagine that probabilities p1 to pm are attached to each outcome or elementary event. So, these are called outcomes or elementary event. So, each one of them has a probability. So, we call it p1, we call it p2. P1 takes a value of 0.5, P2 takes another value of 0.5 and so on. Then the expected value of a random variable x is expected value equals to P1 x1 plus P2 x2 and so on up to Pm xm, and then we are summing it up. Now, just notice here only one difference is that here we are assuming h and t. Now, h and t cannot be here. So, most often in this kind of expressions we will be dealing with some monetary values. For example, if you get a h, then you obtain 10 rupees. If you get a tail, then you have to pay 10 rupees. So, I can have two values of 10 and minus 10. In that case, as you understand that the expected value would be 0, because I will be having 0.5 multiplied by 10 plus 0.5 multiplied by minus 10, done. For example, imagine that in a game you win $3 if a 6-sided die is thrown and 1 or 2 comes up, and you win $12 if 3, 4, 5 or 6 comes up. An individual can get $3 with probability 1 by 3 because you are getting 1 or 2. So, you apply the OR rule. The possibility of 1 coming up is 1 upon 6, the possibility of 2 coming up is 1 upon 6. I simply add them to arrive at 1 upon 3. In a similar fashion, the rest of the numbers 3, 4, 5, 6, if anything comes up, then you are going to get $12. By following the same principle, I can obtain a probability of getting any one of them, that is between 3, 4, 5, 6 is 2 by 3. So, how do we write the prospect? We write the prospect that I will be getting $3 if 1 or 2 appears. The probability of 1 or 2 appearing is 1 upon 3. I will be getting $12. If anything between 3, 4, 5 or 6 comes up, the probability is 2 by 3. The expected value of this lottery will be simply 1 by 3 into 3. So, probability multiplied by the outcome, and then probability multiplied by the outcome, it turns out to be $9. We just need to remember the outcome here is $9 because I might be using it in the following slides. If you could choose between this bet and getting $9 for sure, then which one would you choose? Now, again here the short prospect is $9. So, I can write it as 9 or I can 9 or I can simply write it as 9. In economic experiments with such a choice, most people choose $9 for sure rather than a game with risk. Such experimental results are consistent with the fact that many people try to avoid risk in economic choices in real lives, and we call them risk averse individuals. Expected utility theory explains a person's risk aversion by predicting that she will choose a lottery that gives her the highest expected value of utility rather than choosing a lottery that gives her the highest expected value of money prices. So, now see, we have started differentiating between money prices and utility. So, money prices have been, in the previous example, it was $3 and $12. What we are trying to say is that it is not necessary that $3 is going to give me some utility, which, say, if I multiply 3 by 4, then I will be arriving at 12, right. So, here the winning amount is 4 times higher than the winning amount when 1 or 2 comes up. But what it says is that when it comes to utility, it is not necessary that utility from obtaining $3 is 4 times the utility of obtaining $12. So, this is not necessarily true, that nobody guarantees that this is going to happen. So, now we are moving from money prices to utility, and people basically go for the highest expected value of utility rather than highest expected value of money prices. Consequently, the expectation principle considers the expected values of the utilities associated with the outcome and is written as something like this. So, now instead of having P1 x1, I am having P1 u x1, Pn u xn. So, the probability of the nth outcome occurring and the utility associated with the nth outcome. Similarly, the probability of the first outcome occurring and the utility associated with the first outcome, and all of them are summed up in order to arrive at the total utility or expected utility. This is what is expectation principle. This is what is expectation principle under the expected utility theory. Here u x I refers to the utility from outcome I. Next, we talk about the second tenet, which is asset integration. Imagine that the individual holds E dollars as her initial endowment, and the additional gains from profit or losses from the stock price movements are denoted by X, or it could be stock price movements, or it can be additional gains from any gambles, including the gamble that we just considered in the previous slides. The individual's expected value of utility in that case will be the initial endowment plus whatever he or she gains. So, if there are several alternative outcomes possible, then again I have the initial endowment plus the first outcome, initial endowment plus the nth outcome. So, now the utility is not only dependent on the additional gain, but it is actually a function of what you have and then what is added to it, and then each outcome has multiplied by their respective probabilities, added up, we arrive at the expected value of the utility, which considers the initial endowment plus the outcome, and then summing up we write it like this. Now, suppose we have a specific form of utility function. So, u x equals to logarithm of x, we specify it as the utility function, and consider the previous example. Now, suppose the initial endowment E is 10. The individual playing a gamble has $10 in his or her pocket, and then he is into a gamble. Let us see what are the prospects she has of winning something or losing something. So, if I continue with the above example, the previous example of throwing a dice with prospect of 3, 1 upon 3 and 12 with a probability of 2 by 3, then because now he or she has $10 initial endowment, so $10 plus 3 becomes 13. So, logarithm of E plus x1 is logarithm of 10 plus 3. Here x1 is the first outcome, which is 3, and that turns out to be 2.565 approximately. Similarly, logarithm of E plus x2 is logarithm of 10 plus 12, the alternative outcome, right, the second outcome, that is logarithm of 22, which is approximately equal to 3.091. The expected utility from this lottery is 1 upon 3, that is 1 upon 3 multiplied by logarithm of 13, then 2 upon 3 multiplied by logarithm of 22, and that gives us roughly a value of 2.91. If compared with the prospect of getting $9 for sure, the expected utility will be logarithm of 19, because my initial endowment is 10 and I am getting a sure gain of 9. So, 10 plus 9, 19 makes it approximately equal to 2.94. Therefore, if the individual has the utility function of logarithm of x, then she will prefer getting $9 for sure to the lottery in the above example. So, what we observe is that we claim that an individual is risk averse if he goes for a sure gain of $9. Now, a risk averse individual will be preferring going for a sure gain, and he or she is having utility function which is like u equals to logarithm of x, right. So, it is possible that logarithm of x is a concave function. Next we will be talking about that, but before that I will be formally defining the asset integration concept. So, formally x1 p1 to xn pn, that is the prospect is acceptable at asset position w, which is basically the initial endowment, if and only if the utility from alternative prospects multiplied by their probabilities is greater than the utility from the initial endowment. So, what simply implies is that if the prospect basically provides additional value, as a result of which there will be additional utility, then only this prospect will be acceptable. So, this is the concept of asset integration. So, a prospect is acceptable if the utility resulting from integrating the prospect with one's assets exceeds the utility of those assets alone. Thus, the domain of utility function is its final states rather than gains or losses. Final states implies which includes one's asset position. Now, imagine an individual with $10 initial endowment who is thinking about either receiving a dollar amount for sure or receiving the bet having prospect like this. So, this is the previous example we are continuing with. She will be indifferent between receiving the bet and receiving a certain amount of money for sure if the certain amount is about $8.45. Now, suppose I am now note that here I am talking about indifference. So, previously that individual preferred $9 over this prospect, right, which means $9 is strictly preferred to this prospect. Now, I am talking about an amount say x with which the individual is basically indifferent between this amount and the prospect, and this amount turns out to be 8.45. How? This is simply, this is the initial endowment, and if I plug in the value of 8.45, then I will be getting approximately value of 2.92, which is equal to the expected value from the prospect. So, as a result of which I can say that 8.45 gives approximately the same value as the prospect. So, the individual would be indifferent between having this amount and going for the prospect. So, indifferent in the sense that he would be as good as having the prospect or this amount, not $9. The certainty equivalent of a bet is the sure amount of money that an individual views as equally desirable as the bet. Let us call it Y. Then utility of the initial endowment plus the certainty equivalent is equal to utility plus the initial endowment plus the amount that is coming from the prospect, or expected value of the utility from initial endowment plus the prospect. A risk premium is the difference between the expected value of the bet and its certainty equivalent. So, for example, in the previous case our Y was 8.45. So, all we tried to say is that utility from the initial endowment 10 plus 8.45, that is 18.45, was equal to the expected value of the utility from the initial endowment plus the prospect that we had. We just mathematically shown that these two numbers are the same. So, the individual is different. Now, a risk premium is the difference between the expected value of the bet and its certainty equivalent. The difference between the bet's expected value Ex and its certainty equivalent, which is Ex minus Y, is the risk premium. So, in the above example, if you remember, the expected value of the bet was 9. So, here the risk premium is $0.55 because the difference between 9 and the certainty equivalent 8.45 is 0.55. This is one way of finding out the risk premium in this context. Now, there are three possible kinds of attitudes towards risk for an individual. If the risk premium is positive, then she is risk averse. In the sense, if I am looking for a positive risk premium, then I am a risk averse individual. If the risk premium is negative, then she is risk loving. So, basically I am not looking for a risk premium. Here by risk premium I mean that, for example, we all know in investments where the risks are higher, then the returns are also higher, right. So, the idea is that when I am going to take risk, I want to be rewarded for that, and that reward comes through higher return. Now, a risk loving individual might not look for substantially higher return because she or he has substantial appetite for risk. So, risk premium is negative, risk premium is 0 when someone is willing to take risk without looking for reward. If the risk premium is 0, then the individual is risk neutral. It is presumed that most people are risk averse and their risk premium for a lottery is positive. So, most people would look for a positive risk premium. A person is risk averse if he prefers the certain prospect X to any risky prospect with expected value X. So, that is what we have been trying to discuss, that if a certain prospect 9 is preferred to a risky prospect whose expected value is also 9, then this individual is basically risk averse. In expected utility theory, risk averse is equivalent to the concavity of the utility function. Concavity of u implies that the double derivative of the utility function is 0. The prevalence of risk aversion is perhaps the best known generalization regarding risky choices. It led the early decision theorists of the 18th century to propose that utility is concave function of money, and this idea has been retained in modern treatments. Now, I will present a simple example to show how the functional form of utility can actually imply concavity, convexity or linearity of the utility function. Suppose you have 20,000 rupees in your bank account and you also have a car which is worth 50,000 rupees. These are hypothetical numbers taken just to facilitate comparison, and I will be using only the numbers, the K's are that is why put in bracket. You are considering what kind of car insurance to go for. You have three alternatives. Full coverage will cost you 7,000 rupees, only third party will cost you 4,000 rupees, and you can also go for no insurance. That is the third option you have. But if you do not go for any insurance and suppose police finds you, then they will basically slap you with a fine of 20,000 rupees. Suppose the probability of an accident or car theft is 0.05. In both cases, what I am assuming here is that the entire value of your car will be gone. If the car is theft, you lose 50,000. If it meets with an accident, you lose complete 50,000. And the probability of one of these happening is 0.05 and police intervention is 0.2. There is 20% chance in case you do not have, or 20% chance of police intervention. In case you have an insurance of either type, nothing happens. In case you do not have an insurance, then the police fines you of 20,000 rupees. What is the full coverage aspect? The full coverage aspect is that, see, your total worth, initial endowment is 20 plus 50, which is equal to 70. If you are going for a full coverage, then that is going to cost you 7,000 rupees. So, 70 minus 7, that gives you 63. So, here you are spending 63, that takes care of all possible uncertain events, in the sense car accident, theft or police intervention. You do not have to pay anything additional in case any of these happens. That is why it is a sure prospect of 63,000. What is the third party prospect? Third party prospect is when you basically pay 4,000 for your insurance. So, first of all you would be left with 70 minus 7, that is 66,000 rupees, and your total endowment in terms of valuation of your car plus your bank balance, and there is 95% chance that nothing is going to happen to your car, because the car theft or accident is only 0.05. So, nothing is going to happen to your car. You just spend 4,000 rupees, your total valuation remains at 66,000. But in case there is an accident or car theft, now you see that since it is only third party, your car value is gone. So, there is 0.05% chance that you would be left with only 20,000 minus the insurance amount that you have already paid, which is 4,000. So, 16,000, right. Police is not going to bother you, that is why that does not come into picture. And what is the no insurance prospect? In case you have not gone for insurance and none of these happens, so neither police intervenes, nor there is an accident, nor there is a theft, then you have total 70,000 left, which is the possibility of 75%. In case police intervenes, they will take your 20,000, you would be left with only 50,000 worth of car, and in case there is an accident or car theft, which the probability is 0.05, then you would be left with only 20,000 in your bank account and 50,000 would be gone because the car is gone. So, I have mentioned the prospects here again, and I have given them names like full coverage is option A, only third party is option B, and no insurance is option 3. So, what are the expected payoffs from these three options? They are, first of all, expected value from option A is 63, expected value from option B is 63.5, and expected value from option C is also 63.5. Next we consider three alternative utility functions to map the relationship between utility functions and risk preferences. We are considering a linear function, a concave function and a convex function. So, you can understand that a concave function, as mentioned, its double derivative is less than 0, a convex function has a double derivative which is greater than 0, and of course, a linear function has double derivative equals to 0. Now, for each functional form, I have full coverage, third party, no insurance values, and then what are the predicted choices. So, for linear function, that is ux equal to x, of course, full coverage would be 63, third party would be 63.5, and no insurance will also be 63.5. These are exactly the numbers which are equal to the expected value. In case of concave functions, in root x, I will be plugging in the values, different values of x. Instead of having directly the value of x, I will be plugging in the value of x as they are given in the prospect. And then it turns out to be 79.37 for full coverage, 79.18 for third party, and 79.13 for no insurance. You can see that this is the largest number here. So, full coverage will be chosen here, that is the maximum utility. Maximum utility is generated by full coverage option, and that is why the individual would go for full coverage. See, this is a concave function and the individual turns out to be a risk averse. Now, if I go for a convex function, then the values are calculated as 79.38, 83.02 and 83.90. Now, 83.90 here is the largest value, which simply implies you should go for no insurance. The maximum value is generated by the option of no insurance. So, no insurance implies that the person is the individual is willing to take risk. So, we call them a risk loving or call him or her a risk loving individual. So, this again shows that when the functional form of utility is convex, then the person is a risk loving individual. In the next, I will be showing you the graphical forms of these utility functions, but that would be done in the or will begin the next module with those analysis. I conclude this section here. These are the references. Thank you so much.